it may be 1 or 2 ohms, but if additionally you have a bide Q because you just have wired a piece of wire, you can have 2, 3 or 4 ohms there. So you are getting more, more and more losses. So that's a very important, this graphic is very important to determine, to take your decision.
Is that in the antenna or ON4UN
It's
has
in
that?
the,
Yes,
it's
yes.
in the ARRL book as well.
Okay.
Yeah.
So what you see also is, for example, we are on 80 meter with a quarter wave, and you want to switch from SSB to CW. In this case, you can make the shorter, you can tune your antenna on the shorter band, which is the SSB, and then add a little coil to switch on CW. But as we are very close to 90 degrees, there will be few effect on the gain, on the efficiency of the antenna. So don't confuse the loading coil, which is really made to compensate
Electrically short antenna.
the 8, and a coil just to match the antenna.
Yeah, it's totally different.
Completely different.
Yes,
Yeah.
but don't miss another thing, that if you have a short antenna, okay, and you put a coil here to adapt, that's a loading coil. It's not a matching coil. You see what I mean? Because the guy say, oh, I take an antenna and I put the coil in the antenna. That's
That's a loading coil.
that's a loading
That's
coil.
loading, yeah, and
Yes,
matching would
loading
be
at
in
the same time.
parallel.
So if you put the same antenna, a coax, and you put the coil there because you have a matching,
Same thing.
the problem is the same, okay?
So there, I thought.
But if you
I thought
connect
were
the
making
coil-
a distinction between.
Now the reason, I think the reason, I'm not, the main reason is, as the antenna is shorter, most of the current is at the base of the antenna.
Yes.
And then most of the field is close to the ground, and that's increased the losses. That's why, in this case, you absolutely need to have a perfect ground. So if you want a short antenna, you
Maybe.
can, but with a very good ground.
Good
100 radials,
Yeah.
halfway long. So that's why I say that the vertical part of the antenna is just the summit of the iceberg. Okay? Because what what happens at the ground is a big deal. So what do you prefer? To build an antenna with 120 radials, etc., or just a dipole? And actually a little high. So actually, when you're on the high bands, there is no picture. You have to use an horizontal antenna.
So these
You use a vertical just when you are not able to get high.
yeah, so these advertising, 160 meter, 20-foot antenna, no radials, you know.
Yes.
It's so
Yes, sir. So, inductor calculation, just see that you can go on ON4UN for both. Okay? So, now we will see about because that was only the near field problem. But you also have the far field problem.
Okay.
So, the takeoff angle are influenced by distance, good reflection, absorption. So, I will be fast because we have few time, but I did not understand this graph. I explain what you write. That's it. What happens? So I go back to the board. What happens is, when you have an antenna, okay, over the ground, you have the ground, and somewhere far, here, you have the direct signal of your antenna, and some reflected signals. Okay? At one place, you are supposed to have one reflected signal, but if you take a higher angle, because here we are at 0 degree, if you take a higher takeoff angle, you will get something like that. So that's the influence of the ground. What's happened is that you have the direct signal, like an antenna in a free space, and you have the reflection of your signal on the ground. That's the ground effect. And as you can see, the two signals are not parcourir
No,
uh,
travel.
Multipath, it's multipath.
are not traveling the
Yeah.
same length.
Mhm.
Okay, so there are a few chances
They're out
that
of
they
phase.
came with the same phase
Yeah.
there. So you can imagine that in sometimes they are adding when the phase are in the phase, and sometimes they are destructing together. You have nothing. That's the notch that we can see on most of the patterns.
Patterns, yeah.
You see when you see something like that here, you can think that you have a destruction of the two paths.
So that's not, the notch itself is not because of two paths, because that's only in one direction, right?
No, because of two paths. We are on a vertical plane, okay? And when you are there, it's because this signal is coming 180 degrees or
Oh,
nearly.
that's caused by the
Oh, it's
phase.
because of the ground reflection?
Yes, because
Yes.
of the ground reflection. That's the effect of the ground. So,
That's where the cancellation
but
has.
the problem is not so that simple because that's not a mirror. And you know, at each reflection, you have absorption and you have phase rotation, and not 180 degrees like in the light
In the perfect world.
physics lectures. No, it's not perfect at all. And for the vertical polarization, that is what we get. So take a moment to see that. You have two graphs in one. About the phase, here is the phase, okay? That's the phase curve. That you can see that depending on the angle, so arriving number, the phase is changing very fast on vertical polarization. For example, here you have for 0 degree you have 180 degrees. So the wave is reversed by the reflection. When going to higher angles, the one which are interesting us between 0 and 15, let's say, all the wave is nearly reversed, and at the same time there is some absorption. For example, at 15 degrees you are only 70% of the signal which is reflecting, 30%.
Oh, that's the
so,
angle coming into
Yes.
the ground. Okay.
So what that means,
Wave
the
angle,
curve,
right.
and you can see that according to the wave angle
Yeah.
of the reflected signal, okay, the phase change and the absorption are not the same. And not only that, but it changes with the frequency. That's for 21 megahertz.
So the worst absorption is around 15 degrees.
Yes. So you have a very
high absorption.
Yes.
And ça varie par
That
fréquence.
could be also another mean to have a notch. It's because a small notch, not deepness, but a notch because you only have half of the signal in this case, you know, compared to the maximum.
It's also unpredictable, right? Because it depends on the
Exactly,
characteristics
it's very,
of the
yes,
ground. again.
exactly. That's what I wanted to show you.
Like you said, the wave could go in the ground.
This
Yes.
wave angle, sorry, you said, is it measured from the horizontal or is it measured from the vertical?
A good question. That's a good question. I think it's that one, but I cannot. Ah, sorry. What happened?
It's okay.
I restarted.
I can read the book, I suppose.
No, because actually the book is not clear.
Okay.
It's clear for the vertical, but for the horizontal it's not clear at all. It's why I show you the vertical in front. What I wanted to show you is that it's very, very complicated. It's not very simple. No.
Well, it's easy to see because direct 90 degree,
Mhm.
it's 0 degrees, it bounces back.
If we go 0 degree, we have. I think it's that angle. Yes,
That angle.
I think it's that one.
It's hard to see.
Yeah.
I think, but I cannot because after that I don't know because is it the same angle? I'm not sure.
No, it can't be, Gilles,
So-
because when you go straight like a mirror,
Yes.
180 flip.
No, but
Or-
that's a phase.
Yes, we have
how
180
you
feet
predict
for
the
0
phase?
degrees, so we can manage that.
Yeah,
This is
that's
that
it.
angle.
That's
But
No.
sorry, 0 D. Sorry, phase.
I think
No, it's-
0
it's-
degree.
it's
0
that
degree, 180, or, yes, I think
It's
that
that
is-
angle. No, it's from here.
it
C'est à
looks-
0 degrés, c'est comme un miroir, ça change 190 degrés. At 0.
you think it's vertical?
Yes, has to be, no?
Perhaps, yes. I have to reflect to that. I cannot, I will not take you
Okay.
some, because you see, when you
Oh.
see that one,
Ah,
that's the same one for horizontal polarization. You can see there is a big difference between two of them, and that surely explains why horizontal polarization is not too much influenced by the ground. Okay? You can see that the phase don't change much, and that only the absorption is changing.
okay.
What I don't understand is that, you know, if this were true, so it were 0 degree, why have we total attenuation for low angles? I don't understand. For me, that should be there. That should be on 180 degrees. I did not understand
It should be, yeah.
this. I don't understand this graph. So perhaps you are true, but
This is
in any case, all the angles are
But
zero.
that doesn't make sense then.
No, I don't understand that.
No.
So it's surely true, but I am not able to interpret it. There is something missing.
The other one makes sense, not
Yes.
this.
And the explanation in the antenna book is not clear
No,
because the guy is referring to the image of the antenna,
below ground.
you know, and then he says, ah, yes, but
Oh, yeah,
if
yeah,
you
yeah,
take the
yeah,
image,
yeah.
blah, 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 hey, we have an antenna. No, no.
C'est comme la lumière, il traite.
Yes.
C'est pas la même chose.
But what is important to think is that what I wanted to point out for you, because you are not calculating the pattern by yourself, is that one, the vertical and horizontal are very different and there is some explanation. And two, depending on the ground quality, the thing is changing much with vertical antennas.
More influence,
Except
yeah.
for water, seawater, where we know that it's perfectly flat. And so let's go further. What we call the pseudo-Brewer angle is the angle for which the wave are turned by 90 degrees, halfway. Okay, and in this case, if we go back, here is the
Brewster angle.
The Brewster angle, you see, it's at 15 degrees, where there is a rotation of 90 degrees. Why this angle? Because when you pass the 90 degrees, it's the moment where you start to attenuate your signal.
Yeah.
Okay? So we can see that this, for the
Actually, it looks a
the
lot like a
saltwater,
magnitude phase plot.
okay, it's virtually there are never losses.
Second order filter.
Yes, at any frequency, and for the average ground, you can see that there is a variation according to the frequency too. That I wanted you to see. That means that this curve is moving with the frequency.
Sorry,
So-
can you go back to that?
That is the reason of the problem of the low angles for the vertical polarized waves, and of course the worst is the ground, the worst is the pattern there. Always the same story. So
Moving.
with the vertical polarization, you have ground losses, and you can you can solve that with radials, but you also have the rising of takeoff angle, and the only solution is to move.
Move to where? What? Move the antenna?
On the top hill,
Oh.
near to the seaside. Okay?
Which is why it's handy to have a mobile.
That's what you mean by moving.
Yes,
your
moving.
Vertical antenna on a mobile.
Yes, move to a
Drive on
better
top of the
location.
mountains and then brag about your signal on your mobile
Exactly.
station. Yeah.
So, I think it's 2 o'clock, so we can finish now. I think we're finished. Then just something about the vertical network, because I don't think it's of interest for you, so we can
Vertical
finish there.
networks?
Or we can continue a quarter if you want.
Je pense que c'est bon.
On arrête, okay. So, as I told you, I've shown you, we have scanned all the topics about the antennas, okay? it is some repair for you to read more further. And now it's up to you to read further and to make your own simulation, etc.
Thank you.